Extreme hydrologic events, such as flooding, impact people and the environment and delay sustainable development in flood-prone areas. Extreme flooding events in Ethiopia, such as the 1996, 2006, 2016, and 2020 flood seasons, have impacted people and destroyed their homes and businesses. We developed a seasonal flow forecasting system to estimate the floodwater availabilities and to reduce recurrent flooding impacts in the Awash and Omo-Gibe basins of Ethiopia. The North American multi-model ensemble's in situ satellite-driven precipitation and temperature forecast data over 180 days were used for the seasonal flow forecasts. Historical Climate Hazards Group's infrared precipitation with station data with a 0.05 degree resolution were used to connect the precipitation patterns from the past to future forecasts. Digital elevation model, land use, land cover, and soil data were also used in the model basins. Global data is biased, and so the griddled precipitation data were bias corrected before being used in the model. A hydrological model was used for the seasonal floodwater forecasts and estimation of reservoir water level. The one-layer deficit and constant loss method were used for continuous simulation of changes in moisture contents. The modified Clark spatial distributed method was used to transform excess precipitation to direct runoff in the process. And the Muskin-Gum-Conge routing method was used to combine the conservation of mass and the diffusion of momentum. A hydrodynamic Model 2 dimensional mapper was used for flood inundation mapping and to estimate flood depths over the flood-prone areas. This study produced bias-corrected spatio-temporal rainfall distributions in the model basins, seasonal runoff flow forecasts, flood inundation maps and estimates of flood depths over flood-prone areas, and forecasts of reservoir water levels and storage. The in situ satellite-driven precipitation and temperature data were used to estimate the excess floodwater retained in reservoirs and to reduce flooding impacts. The amount of water to be stored in and released from the reservoir can be decided based on inflow amounts and future water requirements for irrigation and hydropower generation, and of course to protect flood-prone communities and infrastructure from the likelihood of flooding. In general, the seasonal floodwater forecasting system can inform decision makers about future water resource planning and flood early warning systems to reduce flooding impacts.